Hello, my name is Frank. Today I want to show you how to make blue light emitting cadmium sulfide nanocrystals. Basically, it's like cooking. So what you see today is a lesson in nano cooking. Okay, before we start, security first. Protection glass. And because we are dealing with cadmium, we should not get in touch with it. Alright, ready, here we go. So like if you cook something, what you need your ingredients. Here we have all the chemicals we need to make the cadmium sulfide nanocrystals. We have our heating system, which is not an oven in our case, which is a heating gun. So here we can adjust the temperature, what we need. Here we have our thermosensor, our temperature controller. We need a stopwatch to take the time. And when we have prepared our nanocrystals, of course we cannot taste it, we cannot eat or drink it. So how we know if we have good quality nanocrystals? We need to characterize them. So at the end of this lesson today, we have a UV table. So if we excite these particles with UV light, they should have a nice blue luminescence. They should emit blue light. And we have here an absorption spectrometer to see the absorption characteristics of the cadmium sulfide nanocrystals. Alright, we come back here and we start. So what we need to make cadmium sulfide nanocrystals? We need a cadmium source, which is cadmium oxide. But be careful guys, because cadmium oxide is very toxic. It looks like this, a brownish red powder. Cadmium oxide must be dissolved in lauric acid, which is a fatty acid which contains 12 carbons. You can also take stearic acid with more carbons like 18 or hexanoic acid. Does not matter. It's a white powder, so it's not harmful. So if you mix these two things together, you should be very careful. You should do it under Schlenk conditions, and at about 200 degrees the cadmium oxide dissolves in lauric acid and you get a white solid stuff. This white solid stuff you take out and you pulverize it with a mortar. Alright, and then we have our precursor, which is a white powder. Cadmium laureate, it's called. Alright? We make cadmium sulfide, so our sulfur source, it's elemental sulfur, no problem with this chemical. It's ladle, it looks like this. And the sulfur we have to dissolve in trioctylphosphine, shortly top. It is a colorless liquid, but also take care with this liquid because it's harmful for the eyes. Alright? This also you mix together and heat at about 150 degrees, and after a few minutes you find a colorless solution which is sulfur dissolved in trioctylphosphine. This is our sulfur precursor. Okay? So, and we need a solvent. Solvent in our case is alcohol. I mean not the alcohol which you think guys you can drink. No, it's an aliphatic alcohol. In this case we use tetradecanol. It has 14 carbons, but also in this case it does not matter. You can take like 12 carbons or 18 carbons, does not matter. It's a harmless chemical. You see it's a white solid stuff. Okay, here we go. This is our reaction vessel. Very simple, right? So, let's start the nano cooking. Now, we take from the cadmium precursor 6 small spoons. 1, 2, 3, 4, 5, 6. Okay. We take 2 big spoons from our solvent, which is the alcohol, the tetradecanol. Yeah, 2 big spoons like this, it's okay. And the sulfur precursor, which is sulfur dissolved in TOP. It's, in this case, we have a 1 molar solution. That means it's like 30 milligram of sulfur dissolved in 1 milliliter of this trioptylphosphine liquid. So there we take, what is the smallest amount we can take? Roughly 0.1 milliliter, it's okay. And the liquid is inside? Yes. Careful with the needle. Come on. Alright. Now we do very, very simple old school chemistry. So we set our temperature, whatever. Let's heat the stuff up. And the alcohol is melting. So this should then have like 60-70 degrees. And we have a colorless solution. So now we're waiting for the nanocrystals to grow. And come on, where are the nanocrystals? Should be in a second. Don't worry. Yeah, we see a color change. Slowly. A yellowish color. Yeah, that shows that our nanocrystals start to grow. Alright, very nice. Oh my God. Oh my God, oh my God, oh my God, what happens, oh my God. Oh my God. Of course, what we forgot to control the temperature. Sure. Okay, sorry guys, that's the same thing like you cook and you burn your meat. I'm really sorry for this, but of course, honestly, I planned this joke. Because I want to tell you something. You see this color? It's like gray black. Actually what happened is that the cadmium precursor is not stable in alcohol above a certain temperature. So now we did not control the temperature. I set it to 500 degrees. So what happened is that in alcohol the cadmium stera decomposes and into elemental cadmium, you know, that we have proven, you must believe me. So that means we now must use the temperature sensor, and we know from our experiments that we should not go above 200 degrees for this, because this is a pretty embarrassing side reaction arriving from the instability of the cadmium precursor, the cadmium carboxylate in alcohol. Okay guys, so that can happen if you cook too, right? So let's quickly restart the experiment, but this time we must control the temperature. Again, 6 spoons, small spoons of cadmium laureate. 3, 4, 5, 6. Sorry to take your time, guys.
Can I see really cadmium laureate?
Yeah.
Yeah.
Of course. I'm not kidding. Of course we prepared that before, because you need a Schlenk system, of course. You should not do it at home, guys. Alright. Maybe, Michael, you can tell some jokes that it's not becoming boring?
No, you're making the jokes now.
Okay. I'm a chemist, not a comedian. Anyhow, okay, 2 big spoons in there. I don't want to spoil up the experiment again. And da-da-da-da, 0.1 roughly milliliters of so, but now guys, we must control it. So let's say this, we set the maximum temperature to 250. Okay?
Okay.
You see?
Yeah.
230. Come on, come on, come
40.
on. It's Friday evening. You wanna go home? Or party? Okay, we have 250. So now we do it in the right way. We have here our temperature sensor. Put it in. And now, let's say, not to waste your time too much, guys, we say 5 minutes. Okay, here we go. 5 minutes. Das unterlegen wir in Mucke. Okay. It starts to melt. Alcohol at about 50 degrees. CdO. Now we have a colorless solution. 30 seconds passed. 100 degrees, more than. So 1 minute passed and we reach 200 degrees. Okay, now we should stay with 200 degrees. And we see the color change. Michael, can you see it?
Yes, I can see.
Slightly yellow. The nanoparticles start to grow. Cadmium sulfide nanoparticles. The yellow color. So we should, this time we should control the temperature. It should be around 200. So we avoid to go much higher. Therefore I lift my arm a little bit. So that between 200 and 210 that I can keep the temperature there. The particles grow. No black precipitation, very nice. Okay, now we have half time, 2 minutes 30 seconds passed. Okay, 3 minutes over. I try to control the temperature. Still 1 minute to go. 200 degrees. Only 15. So 4, 3, 2, 1, 0. 5 minutes over. Alright, so 5 minutes, 200 degrees. Okay. Here, Michael, you see our nice cadmium sulfide nanoparticles. Nice yellow color, right? Our nanoparticle dispersion. Okay. So, as I told you before, we cannot taste it and see how the quality of these particles are, so we need to characterize them. Therefore, we now want to see them shine under the UV light. We take an aliquot. Okay. And chloroform. Chloroform is the solvent we disperse our particles in. Okay, we let them cool down a little bit. They're still hot, not really hot, but okay. So, no. We put the chloroform in. We shake, and here you see, now this we can take out, Michael, no problem. You can see the dispersion of cadmium sulfide nanoparticles. Okay. So,
Looks good so far.
switch off the light, and let's see how they perform under UV light. You, Michael, you excited?
I am.
Yeah, me too. Alright. Open the stage for the cad sulfide nanoparticles under UV light. Come on.
Yeah, nice.
Yeah, you see the deep blue luminescence, like violet style. Okay. Let's take an absorbance spectrum. Once again. Whoa. Michael,
Wait.
look at this deep blue luminescence from cadmium sulfide. Okay, let's go. And here we go. Oh, they're pretty. Wait. They're pretty concentrated.
Oh, yeah.
Give me one
Pressure.
second. Give me 1 second. They are too concentrated. Oh my god. They are too concentrated. Just let's see another time under UV.
Yeah.
Okay, you see?
Very nice.
Now we should, with the absorbance, this is much too high. Okay. Voila! Ladies and gentlemen, here you see our cad sulfide nanoparticles with the absorption maximum peak around 410. Alright, nice absorption features. You can see that is a good quality of cadmium sulfide nanocrystals. And once again, because it was so nice, Michael, let's see again the nicely luminescence of these cadmium sulfide nanoparticles. Of course, it's not the blue you used to you like to see, the normal blue, but because they are small nanoparticles. I mean, this is in the UV, they emit in the UV light in the deep blue. Okay, so I hope you enjoyed
Yeah, very nice.
our
So
session.
good result.
Yeah, because it's pretty cool that you can do cadmium sulfide nanocrystals, which are their surface is very sensitive, you know, so mostly they look like orange because they have defect states, so that you can in an easy way synthesize cadmium sulfide nanocrystals with this luminescence, without defect luminescence, without this orange, and to have these nice absorptive features. Okay, let me summarize my results. Thanks very much for joining us, and thanks Michael for doing this video. Bye.